Good morning, respected judges and everyone. We are Team GemScan, and today we are presenting our project, an AI powered personalized medication safety assistant. GemScans helps users scan their medicines and instantly checks for the drug interaction, food interactions, duplicate ingredients, and personalized health risk using Gemma-4 running completely on the device. Many people take multiple medicines without knowing whether they are safe together, and the risk becomes even higher for the elderly patients, people with the diseases, allergies, or pregnancy. Existing solutions are often online, generic, and very difficult to understand, but our solution runs locally and makes the medication safety simple and personalized according to the patient's history. Here is how our system basically works. First, the user scans the medicines using the phone camera. We use Google ML Kit OCR to recognize the medicine name from the packaging. At the same time, we collect the patient's information like age, diseases, allergies, pregnancy status, and sleep cycle. This information is then sent to Gemma-4, which runs completely on the device. Finally, the AI generates the personalized medicine safety advice in very simple language. Since everything runs locally, the user's medical information stays private.
So when the application is launched for the first time, the user is asked to complete a patient profile. The profile includes the patient name, age, existing medical conditions such as diabetes, hypertension, kidney diseases or heart diseases, also like pregnancy status, allergies, regular medications, and even the sleep schedule. This information is stored securely as a JSON file inside the application private storage, so it remains available even when the device is offline. Next, the application asks for storage permission because our Gemma-4 model is stored in the download folder. So during the very first launch, the model needs some time to initialize. This is called a cold start. After initialization, the model is cached, so future launches are much faster. Now we are on the main dashboard. Here we can see there is a patient profile icon. I will click on it. It will show all the information that I entered earlier has been saved. So then the user simply taps the camera button to scan medicines. The camera opens after the permission is granted. Here I can scan the first medicine, that is Flagyl. Then I scan another medicine, that is Panadol. In the backend, we use Google ML Kit OCR, an on-device machine learning SDK to extract the medication name directly from the package without requiring internet. Next, I enter the patient symptom. For this demonstration, I entered headache and diarrhea. Now the interesting part began. Our backend sends the OCR result, the patient profile, the symptom, and the set of predefined medical safety rules to the Gemma-4 model. These predefined rules include safe dosage limit, interaction constraint, and validation rules that help reduce hallucinations and keep the responses consistent. The model now generates a patient-friendly explanation. Instead of using difficult medical terminologies, it explains the risk in simple language and provides practical advice that anyone can understand. Because the patient profile includes kidney disease, the model also considered that personal condition while generating its recommendations. Below that, we are provided with an explainable AI reasoning. So instead of only showing the final result, the application explains how the conclusion was reached. It shows the patient profile, the detected medicine, the identified risk, and finally the recommended advice. This makes the AI decision much more transparent and easier to trust. Finally, the application also displays food and timing notes. These explain important interactions, just certain medicines with meal to reduce stomach upset. So it is also recommending me to not take the Panadol extra in evening because it contains high caffeine dose which can disrupt the sleep cycle. These recommendations help patients use their medicines more safely. So this demonstrates how GemScan combine patient history, medicine recognition, local AI reasoning, and explainable recommendation into a completely offline medication safety assistant. Now let me demonstrate another scenario. This time I added the patient profile. I changed the patient age to 30 years and add hypertension as an existing medical condition and set aspirin allergy and update the sleep schedule. The updated profile is automatically saved and will now be used by the AI during analysis. Next, I scan two medicines, Dispirin which contain aspirins and Panadol extra. I also enter the patient symptom before starting the evaluation. Now notice how the AI personalizes its response based on the patient medical history. Instead of giving general medical information, instead of giving only general medicine information, it considered the patient hypertension and aspirin allergy while generating the advice. At the top of response, you can already see the model mention the patient hypertension and explain why extra care is needed. It also recommend avoiding aspirin because it can upset his stomach. If we look at the explainable AI reasoning flow, we can clearly see how decision was made. For example, it explained that Panadol Extra is generally safe, but because the patient has hypertension, the correct dosage should be confirmed with the doctor. Similarly, Disprin is flagged because the patient has recorded aspirin allergy. This demonstrates that GemScan does not simply recognize medicine. It combines the scanned medicine with the patient's medical history to generate personalized, explainable, and safer recommendations.